Hey there, sixth grade, lesson 11. We're working on volume today. This is going to be a doozy of a lesson, so hold on to your hat. I think most of you are familiar with the volume formula when we're asked to find the volume of a rectangular prism like these here. I think most of you know that you should multiply the length times the width times the height. But I don't know that you have a real strong concept of what the concept of volume is all about. So volume is measured in what we call cubic units. Because solid shapes like these rectangular prisms has 3 dimensions, they have a length, they have a width, and they have a height. We need a cubic unit, something that has 3 dimensions as well. So when we're asked to find the volume of something, we're basically asking how many cubes of a certain size will fill up that whole space. Volume is a question of how much space is inside, or does that solid take up. And so you need to be real clear that the units that we're talking about are in the shape of a cube, okay? Now, if we're talking about cubic inches, a 1 cubic inch would be a 1 inch by 1 inch by 1 inch cube. This that I have in my hand here is not a 1 inch cube. It is a 1 centimeter cube. All right, I don't have 1 inch cubes, unfortunately, but this is the best example I have. So if I wanted to measure this little box here, I have a little box that I made out of paper, okay? I actually made that for another class. If I wanted to know what the volume of that box is, I'm going to basically pack this with cubes and see how many it will hold. And I can get 4 in the bottom layer, as you can see there. And I'm guessing most of you can see that the top layer will also be 4, and that since the height of this box is 2 centimeters, we have 2 layers. The width of the box is 2, and the length of the box is 2. So this is a 2 by 2 by 2, and sure enough, it holds 8 cubes. So we say the volume of this little box here is 8 cubic centimeters. So that's the concept, and I wanted to be real clear that you understand we are counting cubes when we are calculating volume. Sometimes you're just taught the formula and you multiply and you really don't know what you're doing. So this opening exercise is asking us to answer how many 1 inch by 1 inch by 1 inch cubes will fit in each of these prisms, each of these boxes. Let's just call them boxes. So I am going to first kind of explain it with the cubes, okay? If you have a 1 inch cube, can you see that if this is 10 inches long, I could line 10 up along the length, okay? And this first row on our bottom layer would have 10 cubes in it, because the cube is 1 inch wide, just like this box is 1 inch wide, okay? Now, how many rows are going to be on that bottom layer? 4, because this is 4 inches long, so I can fit 4 that way, and then there will be 6 layers. So the bottom layer is going to be 40. 40 cubes will fit on that bottom layer, but I'm going to have 6 layers, so it's going to be 240 cubes that can fit in that box. Okay? This one, however, will hold 480 cubic inches, okay? 8 times 5 times 12, 8. So I'll have 8 cubes on the bottom layer, okay? It'll be 5 deep, okay? So that's 40 on the bottom layer, but then I have 12 layers, and 40 times 12 is 480. So this box would hold 480, this box 240. Okay, example 1, it gets right to some tricky thinking. So we have a box. It's actually the same box as we did in the opening exercise. This box here is the 10 by 4 by 6. Now the question is not how many 1 inch cubes will fit in that box, but how many 1/2 inch by 1/2 inch by 1/2 inch cubes will fit? That's a really interesting question, and I wonder if you think maybe the answer is half. I don't know what you think. I wish we were together so I could ask you, but let me just show you this little drawing I did, and this will demonstrate. I have a 1 inch by 1 inch by 1 inch cube. That's what I've drawn here. This is 1 inch long. This length, the width is, or the depth is 1 inch, and then the height is 1 inch. Okay. So the question is, how many half inch by half inch by half inch cubes will fit in a 1 inch cube? So 2 will go along here, right? Because that's a half and a half. That makes one whole. And then I will have 2 rows of 2 in that bottom layer. So I've got 1, 2, and then right behind it is 3, 4 for my bottom layer. And then because the height is also 1 inch, I can get another layer of half inch cubes. And altogether, you should be able to see that there are 8 half inch cubes in that 1 by 1 by 1 cube. It's amazing. You wouldn't expect it to be that much more, but it is. So the question is, how many of this size cube, 1/2 by half by half, will fit in this box? Well, all we have to do is take our volume, which we calculated to be 240 cubic inches. Those are 1 by 1 by 1 inches, okay, cubes, and just multiply that by 8. Since we know for every 1 cubic inch, you can get 8 half inch cubes. And the answer is 1,920. It's pretty cool. It's just surprising, I think. I hope you think about that a little bit. We're going to have a lot of more examples to do more thinking along those lines. Example 2 has us looking at 1/4 inch cubes, okay, and figuring out how many 1/4 inch cubes would go in this prism here, okay? So there's 2 different ways you can think about this. I want to start off with just the simplest case where you ask yourself, if I have a 1 cubic inch, so 1 cube that is 1 by 1 by 1, how many 1/4 inch cubes would it take to fill that up? So if this is 1 inch here, every tick mark is 1/4 inch, and you can see there are 4 cubes along there, 4 cubes along there. So there will be a layer on the bottom of this cube, 4 by 4, or a layer of 16, and that's just on the bottom layer of that 1 inch cube. Then you're going to have to build up 4 layers up to get to the top, because again, 1 inch, this is 1 inch, would have 4 1/4 inches in it. So 4 layers of 16 is 64 1/4 inch cubes. That is a lot. So that's the first thing you need to understand, is for every cubic inch, there will be 64 1/4 inch cubes in to fill that cubic inch up. So we could take the volume and just stay in inches, okay, and multiply 1.5 times 1 times 3 3/4. Now be very clear, 6th grade, that I want you to do your fraction multiplication. I don't want you switching to decimals and using your calculator. When you turn in your work, I want to see the fraction multiplication, because you need to practice this. You need to be very fluent in fraction arithmetic for algebra, all right? So you need to keep your skills and keep your concepts clear on fraction multiplication. It might take a little review. You're going to convert to an improper fraction and multiply. You multiply straight across the top, straight across the bottom, and you get 5 5/8. Now, of course, that is in cubic inches. We now need to apply what we found out here and realize that for every 1 cubic inches, there are actually 64 1/4 inch cubes. So you multiply by 64 and you get 360 1/4 inch cubes. Now, another way you could have gotten that same answer is to just ask yourself to think about this question. If this length here, this width or length of the box is 1.5 inches, how many 1/4 inches, how many 1/4 inch cubes can you line up here? 4 for the 1 and 2 for the 1/2, so it's 6 altogether. So that's 6 cubes across here, Now, remember, we're just doing the bottom layer. The width of the box is 1 inch, so that means 4 1/4 inch cubes could be lined up there, and that bottom layer would be 24. Now we're going to go up, and we have to know how many layers we have to build. Well, this is 3 3/4 inches, and we want to know how many fourths are there. Well, there's 4 in 3, so that's 12, but then I add the 3 more, and that becomes, let's see, 3 times 4 is 12, plus 3 is 15. Yeah, so that's 15. Okay, so all we have to do is multiply, so that means there's 15 layers of 24, and you multiply those three numbers together and you get 360 as well. So that's two different ways to look at it. I would imagine you need to rewind and listen to that again and do some thinking on your own, so that you can make sense of it for yourself, okay? Remember, I'm a math teacher, so when I explain it, especially on a video, I go kind of fast, and I need for you guys to take time to make this your own thinking. Okay, because math is all about thinking, right? All right, so exercise 1, we're just supposed to calculate the volume of this box. So this is in centimeters, so we're just going to multiply the length times the width times the height. And we get 4 and 20/27. Isn't that lovely? They just love these gigantically complicated fractions. But that's how I want you to show your fraction multiplication. Now you can use your calculator. To be clear, here's how I would use my calculator on the converting the fraction to the mixed number. I would divide 128 by 27, 128 divided by 27, and look what I get. I get this big old decimal number, but I look at the whole number portion, it's 4. That tells me I can get 4 whole groups of 27 out of 128. So then I just multiply 4 times 27, and I get 108, and then I can subtract 108 from 128, and that's how I know there's 20 left over. So now we're asked, if you have to fill the prism with cubes whose side lengths are less than 1 centimeter, what size would be best? Okay, what size would be best? What they mean is they don't want any wasted space. What size cube that's less than 1 centimeter would fit perfectly into 5 1/3 centimeters? Well, if you have to be smaller than a centimeter, I would say the 1/3 is your best bet. You don't want to choose a half or a fourth, because that would not work out perfectly with this 1/3 that's left over. Okay, so let's just pick the 1/3, and then we know it'll work out. Okay, so let's think real quick about 1/3 cubic inch. I mean, excuse me, 1 cubic inch. How many 1/3 cubes will fit into 1 cubic inch? And I've got a little picture here that I drew. Let me see if I can just. Actually, no, that wasn't the cubic one. Let me show you how. There it is. Okay. Let me show you how to draw a cube while I've got this blank piece of paper, because this may really be helpful for some of you that like to draw. To draw a cube, you want to start out with a square, okay? And then on the top side of the square, you want 2 diagonal lines, and you're going to make a parallelogram on top of that square. And you want it to be, you know, approximately the same size as the square. And that looks like the top of the box. And then for the side of the box, you just want to draw another parallelogram, also, you know, that looks like it's the same size. And you might need to erase and adjust the corners. It's not perfect. I'm not the best at drawing, but it's good enough, don't you think? So all it is a square and 2 parallelograms, and you just make your lines go off, basically 3 diagonal lines off the square, and then all you have to do is connect. So this is a 1 by 1 by 1 inch. Wait, are we doing centimeters? We're doing centimeters. Yeah, sorry. All right, well, I don't need to draw it again because I got it drawn right here. So there's 3 of them. 1/3, 1/3, 1/3 makes 1 centimeter. So I have a row of 3, and then I have 3 rows of 3. So that bottom layer is 9, and that means I have 1, 2, 3. I have 3 layers of 9 1/3 by 1/3 by 1/3 cubes. So there are 27 1/3 cubic centimeters in 1 cubic inch. Okay, there's 27 of them. 3 rows of 9 is 27. So that's helpful to know. And now all we have to do is take our volume, which was this lovely fraction, 4 and 20/27, and multiply it by 27. Okay, well, don't worry. We know the distributive property. We can multiply this in parts. We can multiply 27 times 4 and get 108. And then multiply 27 times this extra portion, which is 20/27, and we get 20. And we find out that it's 128 cubes to fit in that box of the 1/3 by 1/3 by 1/3 size. Okay, now this one says use the relationship between the number of cubes and the volume to prove that your volume calculation is correct. So they just want us to take the number of cubes, which is 128. Now the volume of the tiny cubes, the 1/3 by 1/3 by 1/3, is 1/27. That's the volume. And so if I have 128 cubes that are 1/27 cubic centimeters in volume, if you multiply that whole number times that fraction, you get 128 over 27, which is the volume of the whole box, which we had already calculated. So we are correct. Okay. The next one, exercise 2, is just straight calculating the volume. We don't have to look for smaller size cubes here. So it's just little fraction multiplication review. Show your work. You can use your calculator, but I do want to see the fraction arithmetic there, okay? So you can use your calculator to figure out, if you can't see already, that there's only 132 and 55, and then use your calculator to quickly find out that there's 23 left over. So this is 1 and 23 over 32. Okay, same thing here, just multiplying a bunch of mixed numbers, convert them to fractions bigger than 1, multiply straight across the top, straight across the bottom. You get 62 and 20/27 cubic inches. Just so much fun, isn't it? Yes, yes, yes. We love this. Okay, so number 3, we have toys, at least in our story problem. So we have to package up these little tiny toys. I don't know what they are, maybe little Pokemon men, or I don't know, Pokemon things, but they have to go in a box that is 1/2 by 1/2 by 1/2. So the box, it says cube-shaped box with side lengths of 1/2 inch. So these smaller boxes are then placed in a larger box with the dimensions of 12 by 4.5 by 3.5. What is the greatest number of small toy boxes that can be packed into the larger box for shipping? So I started out, I'm just going to find out the volume of my large box. It's 189 cubic inches. I just multiplied those 3 together. Okay, 12, 9 halves is 4.5, 7 halves is 3.5, and you get 189 cubic inches. Now, I already know that 8 half-inch cubic half-inch boxes can fit in 1 cubic inch. So all I have to do is multiply 189 by 8, and I get 1512. And now this is the same question. Use the number of small toy boxes, the number, which is 1512, that can be shipped in the larger box to help determine the volume of the shipping box. Well, if I know that each box is 1/8 cubic inch in volume, a half by half by half is 1/8 inch in volume, and I know there are 1,512 boxes, well, all I have to do is take the number of boxes and multiply it times the volume for each box, and I get 189 cubic inches. which is what I got up here. So yay. All right, number 4. Now we have a rectangular prism with a volume of 8 cubic units. So we're no longer talking about cubic inches or cubic centimeters. We're just using a generic word called unit. Could be anything, inches, cubes, centimeters, whatever. But whatever the unit is, there's 8 cubic units in our prism. And you're going to fill it twice, fill this prism twice, once with cubes with side lengths of 1/2 unit, and once with cubes with side lengths of 1/3 unit. How many more of the 1/3 unit side lengths, the 1/3 unit side lengths, oh my gosh, how many more of the cubes with 1/3 unit side lengths than cubes with 1/2 unit side lengths are needed to fill the prism? This is quite the mouthful and the brainful too. So slow down and just let's think about this. We already know that for cubes that are 1/2 by 1/2 by 1/2, 8 of that size will fit in 1 cubic unit. Okay, we already figured that out. Each 1 cubic unit will have 8 1/2 cubic units. Okay, so we take the volume of the box, which also happens to be 8, and we multiply it by 8 because we know that there are 8. We know that we have to multiply 8 because of this fact right here. There are 8 half-inch cubes in 1 cubic inch. So we know that there would be 64 half-inch cubes in the box. Now for the third cubic inches, we know that there would be 27 of those for every 1 cubic inch. So we take the volume of 8 and we multiply it by 27 and we get 216. And then we find out that if I'm packing it with 1/3 cubic inches, I can get 152 more. That's quite a lot more for not much of a difference in size. So that's that's kind of how they learn to pack people in airplanes too. Okay, so what does it take? Why does it take more cubes with 1/3 unit side lengths to fill the prism than it does with cubes with 1/2 unit side lengths? Well, because they're smaller. 1/3 is smaller than 1/2. And if the side length of the cube is smaller, it will have less volume. It will take up less space. So therefore, you can put more in the box. Last problem, number 5. Calculate the volume of the rectangular prism. Show 2 different methods for determining the volume. Okay, I'm going to help you out with this. The first method is just to multiply 1/2 times 3/4 times 4.5. Convert to fractions greater than 1 if you need to. Multiply straight across the top. Multiply straight across the bottom. Divide. You have 5 with 1 left over, so the volume is 5 and 1/16. Okay? Now, another way to find the volume is if you don't want to deal with fractions, what unit would fit evenly into all of these mixed numbers? It'd have to be smaller than 1. Would it be 1/2 units? Halves would work here, but halves won't work it with 3/4 because we would have we'd have either you'd have leftover space that wouldn't be used in the box. So let's go down to the next smaller unit and let's try fourths. If we have the 1/4 by 1/4 by 1/4 cubes, can you see that you would fit 6 across this way? Because there would be 4 in the 1 and 2 in the 1/2. So there'd be 6 going this way, 3 rows of 6 because these are 3/4. So that bottom layer would be 18. Now, how many layers would I need? Well, there are 4 meters, and I know I'm doing 1/4 inches, so that's 16. And then I know there are 2/4 and 1/2, so that's how I got my 18. So I could just multiply 6 by 3 by 18 and know that that's 324 1/4 meter cubes. So now I have to multiply, and I know that there are let's see. I know that there are, do we know that? Have we done that? That there are 64. I can't remember if we did that. 64. I think we did. Yeah, we did. We already know that there are 64. We did that right here. We found out that in 1 cubic inch, there are 64 quarter cubic inches. So now I multiply my 324 times the volume of a quarter cubic inch, and I get my same volume. Okay. So, whew, good luck. Make sure you show your work. Remember, you can use your calculator, but I want you to show me what you multiplied, and I don't want these answers in decimal. This is a fraction lesson that you need to give your answer in fractions, okay? So important that you guys be fluent with your fractions, as difficult as they can be to some people. Keep trying. It gets easier.